So main topic for me is mixed reality. It's mixing reality with virtual graphics. So, and how that works. So give you a background on the company. We did a number of projects since 2011. Ever since Microsoft Kinect came out, we worked on a number of 3D projects. And I really enjoyed Barry's presentation earlier because one of the projects we worked on was working on measuring weight of pigs. Okay, and so Barry talked about real world experience. It doesn't get any more real world than inside the pig's barn. I mean, that was, everything you talked about plus more in terms of harsh conditions exist in that kind of environment. So very, very hard to apply technology to real world. So one thing we realized from the very beginning is that the existing approaches, technologies, algorithms, hardware, let's say 2 years ago, none of them was adequate to what we can do today and what we need to do in the future. So it's going to be huge improvement. It needs to be huge improvement coming together. So we are not well known, but a number of big companies have that we're working with tagged us having one of the best 3D computing technologies on the market today. Okay. So if you could just play the video. So this is a scanning technology. So being able to scan with your hands, right? So being able to scan objects in 20, 30 seconds, not 10, 20 minutes is what was done. And scanning objects or scanning scenes is very important because for AR, VR, it's kind of a two-step process. First step, you scan object or scan scene, so you have a 3D model of it. Then once you have that 3D model, you can track based on the 3D model. So you don't do this in vacuum. So once you have that 3D model, if you could play the video. Then you can overlay the graphics on the object itself, so you can provide this mixed reality experience. So that's just using a 3D model of that object. We did an object recognition on that object and superimpose a graphics on top correctly in real time. So, and you have the really old video, but this is. Well, if you go to our website, we also have a scene example as well, where you can track based on the scene. So let's get to our vision of how this mixed reality is going to work. Our vision is that we think that MR needs to be kind of a cross-platform. So if you make a MR or AR experience, you should be able to use your tablet, or you can use your cell phone, or you can put a VR glass where you see real objects in a virtual world, or you can put an AR glass on and see virtual graphics on a real world. So no matter how so there's a lot of companies kind of focusing on developing a single platform solutions. We kind of feel that the solution needs to work across all platforms. Obviously, a very difficult challenge, but I think it's something that could be achievable. So there are 4 key enablers of mixed reality. First is the 3D depth sensor. A lot of the initial approaches were 2D based, but we just know that based on our experience, 2D is just not robust enough for the real world. Next important thing, computer vision. Computer vision has been around for a long time, but we are just like, in terms of human years, computer vision algorithm right now is like 5-year-old, okay? We're just beginning. All those, amazing, the science fiction stuff that they shown there, we don't have that kind of algorithm quite done yet, okay? So it's going to take a lot of work to make that happen. But it is happening. I mean, that's the encouraging part, is especially in the last 3 years, if I look at research papers coming out of the universities and so on, the quality and the complexity and sophistication of those are, I would say, 10 times better than what it was 3 years ago. So it is very encouraging. Processors, lots of different processors, big players, obviously, NVIDIA, Intel, Qualcomm. There's a new company called Movidius. They're kind of an image processor-focused companies. It's hard for me to know at this point who's going to be the big winner out of this, because there's, technology is very complicated. So there's a lot of ways to solve these problems. So it's not clear who's going to win, but definitely there's enough players there, and there's enough potential there to actually make things work, even based on the current platforms. Then there's the computer vision guys like us, who's working on what we think is kind of a brains behind the operation, right? So providing that vision intelligence. And in the AR level, ultimately, all we need to do is really come up with what's called a pose information. Pose information meaning where is the object, how is the object oriented. So that, or if you will, the scene, how is the scene oriented relative to the display device. So it's a very, well identifiable problem, but a very difficult problem to solve. Obviously, there's tons of display guys and more display guys coming out all the time. So I'm not going to talk too much about that. I'm going to talk primarily about the sensors and the computer vision. So for 2011 to about last year, it was quite amazing to me that PrimeSense, the company who kind of pioneered this field, they were still the best. Even as of I would say 6 months ago, PrimeSense was pretty much one of the best sensors out there, even though they were bought by Apple 2 years ago and you can't even buy them anymore. But in last 6 months or so, especially last year or so, you're starting to see these new companies coming out, new 3D sensor companies. They are just much better than what used to exist. And I actually expect them to be on the market sometime next year. We are actually working with one of the companies called Orbac, and they have an excellent sensor, and I have to give them a plug. So, they are one of those companies that just recently came out and have very high quality sensors. Sensors are extremely important. Obviously, sensor quality dictates what we can do in computer vision. Resolution's gotten better, it's much faster, ranges up to 8 meters in some cases, much lower cost. I've seen sensor that prototypes, they are less than 1 centimeter long every direction. So it's very tiny. It's like, it's actually designed for cell phones. It's not on the market yet, but it's coming very soon. Accuracy is amazing, so much better than what it used to be. The old sensor technology, they couldn't scan dark surfaces. You show anything like dark color and especially a little bit reflective, it will not see those points. The new ones do. So the previous usage, mostly for gesture recognition and some simple scene object capture, now you're starting to see that we can use that for AR, VR applications and others, and there's tons of other applications related to that depth sensor. Wait, I don't know what happened there. Okay. Oh, okay, so computer vision, as I mentioned, the initial computer vision algorithms were based a lot on the open source, OpenCV, PCL algorithms. For lack of a better word, by today's standard, most of those algorithms are pretty crappy. They're very inefficient, not reliable. It's focused very much more on the 2D processing. 3D stuff were not very sophisticated. And then, then we started getting to gesture recognition. So now we're starting to get into more complex algorithm. And today, there's a number of companies that are providing basic SDKs and so on. Currently, there's a lot of basic, SLAM. SLAM is the way or means to capture the scene and track based on the scene. And that, a lot of people have that, and it kind of works, but they are heavily dependent on things like IMU, very expensive IMU to provide accurate tracking. And works in a static environment, as long as it's kind of controlled environment and so on. And that's kind of where we are at the moment. But when we see the future, what we want to see is when you capture object, you want to do it naturally, quickly, total rate movement, you can do it with cell phones. When you track, tracking should be very robust, right? I mean, you're tracking inside the room and chairs are moving, people are moving inside the room, you should still be able to track. And that's the algorithm that we need to work toward. You also need to be very power efficient. Given that battery power is extremely important in mobile devices. It needs 90 frames per second or better tracking. It's very important for kind of a natural appearance of the graphics. And it should be able to run on any platform. Currently the platform dependency to me I think it's going to be a big issue. I personally with the HMD guys, many of them has chosen some of these components based on purely more on the cost and power consumption, or sometimes marketing reasons, not necessary for the best user experience long term. So I think that's definitely going to be an issue as well. So please stop by our booth. We have some demos.